Faces there. So I'm going to just kind of give you a little bit of background about myself and my career and talk a little bit about engineering in general. And if you have questions, since you're not all sitting at your own terminals, we're not going to be able to use the chat feature very well. So raise your hand. Mr. Sloan can call on you and unmute the mic. Either you can shout it out or he can repeat the question. Looks like we have a couple other classes on the line. The same goes for you guys. If you have questions, just jump in. I do ask you to stay muted if you're not asking a question, because sometimes that creates a really bad echo. Let me know if you can't hear me. Let me just kind of jump into things. My name is Jeff Leonard. I am an electrical engineer by degree. I got my engineering degree from the Ohio State University. And for many years, I designed both electrical components that get used in buildings, and then eventually started designing the electrical systems within the building. So if you look around your classroom or the room that you're in there at your school, I designed a lot of schools over the years. I would pick out which lights, how many, make sure, do the calculations and make sure there's enough light down on the desk. I would pick where the exit signs go and the emergency lights are needed, where the outlets need to be, design enough power for all of the cooking equipment in the cafeteria there, pick out the size of the transformer so that you have enough power coming to the building. And one of the big things that we do with our circuit breakers and our fuses is make sure it's a very safe electrical system and we don't overload any circuits. I designed all kinds of buildings, hospitals, schools, offices, warehouses, factories for many, many years. And eventually I went to work at Wright-Patterson Air Force Base, which is where I work now. And for a long time at Wright-Patterson Air Force Base, I essentially did the same thing. Wright-Patterson Air Force Base is a city unto itself. We have houses, we have hospitals, we have grocery stores, we have movie theaters, we have a bowling alley, we have offices, we have warehouses, we have hangars, we have laboratories, we have industrial manufacturing places and shops. We have merchandise department stores and everything on the base. And so I was doing the electrical design for those. One of the things that's unique about Wright-Pat, even compared to other Air Force bases, is our Air Force Research Laboratory and some of our office complexes are different than a lot of places. And the Air Force Research Labs are very cool. I'm going to talk about those in just a minute. But I was being the electrical engineer for the base, either designing systems or hiring architects and engineering firms to design them, and being the project manager and reviewer of those projects to get stuff built on the base. And because of all my work doing the fire alarm design, when I'm talking about designing systems in buildings, I'm talking anything in the building, whether we used to say anything that has wire running into it, but then we started using fiber optics. So I had to change how I say that now. But the computer network systems, the fire alarm systems, the PA system, sound systems. I did theaters with all the sound systems in the theaters. So I took all of that work doing all of our fire alarm design, and I became the base fire protection engineer for a while. And I decided who got what kind of fire alarm systems and who got sprinklers and who didn't need sprinklers. And one of the things fire protection engineers do is we look at what we call the life safety aspects of a building. If you look around your classroom, if it's a small classroom with only one door, you probably don't see an exit sign. But if you're sitting there in that big multi-purpose room, you probably have exit signs over doors and more than one exit. Well, that's decided by a fire protection engineer in the life safety code. When you get more than 50 people, you need 2 exits. They have to have exit signs. You have to have emergency lighting in there that comes on if there's a power outage. And I would do all that kind of design work. Did that for a number of years, and then I got the chance to be the chief of our energy section. Energy as an engineering discipline is kind of a unique thing. I was in charge of our $40 million budget for coal, water, gas, electric, and wastewater. We consider wastewater a utility or an energy as well, because we have to pay someone to deal with our wastewater. And we send most of that to the city of Fairborn, and we pay Fairborn to treat our wastewater for us, just like they treat the water from the people from Fairborn. So I managed that energy program for several years, and then I got the opportunity to go to the Air Force Research Labs, and now I'm a safety engineer in the Air Force Research Laboratory. Now, a safety engineer is a very unique engineering discipline. It's that we use in the Air Force and in the Department of Defense that a lot of people don't do. My job is to go into one of our labs, and I work in the Materials and Manufacturing Directorate. We have lots of different labs. We have 5 different labs out at the base. When I work in the Materials and Manufacturing Directorate, my job is to go into the lab, review the experiment or the research that this PhD researcher is doing, and then determine how hazardous that experiment is going to be, help them come up with ways to make it less hazardous. If they're going to use toxic chemicals, we put it inside of a chemical fume hood to exhaust the fumes from that toxic chemicals. If they're going to use some type of flammable, we store it in a flammable cabinet, or we make the reaction take place in a fireproof container. If they're using lasers, we make sure we have the proper laser eyewear to protect our eyes, because even small lasers can damage your eyes. Your eyes will focus that laser beam to such a small amount it can damage your retina. So we make sure they're wearing the proper laser safety, and that the doors lock so that automatically lock, so somebody can't walk in while the laser's going, and that type of thing. So it's really cool. They have to explain their experiment. I have to look at the setup. I try to determine how hazardous it is. I come up with ways to make it less hazardous, and then I document all that on a form that we call our safety permit. So I really get to learn a little bit about everybody's research going on in our directorate. And right now I'm responsible for about 200 different labs, including what we call additive manufacturing, or what you guys know is 3D printing. Do you guys have any 3D printers at your school? Yes or no? Raise your hand. Nope, no 3D printers? Okay. So we have 3D printers, and we're working on building a new lab where we're actually able to 3D print with metal. I don't know if you can see this little cube here, but this was printed a layer at a time in metal using lasers. So 3D printing is the way of the future. So that's kind of about my career. One of the very cool things about working for the Air Force is, and working for Wright-Patterson, is that I have 20 years with the same company, the same retirement system, the same pay system, but I've had 4 different jobs, 4 different career changes by being electrical, fire protection, energy, and now safety, but always working for the same company. So that's been pretty cool to be able to do that. Does anyone have any questions about science, about engineering? One of the things that I was, when I was designing projects, and most of my engineering experience came from the construction industry, but as a project manager, I got to supervise a lot of the other disciplines, the structurals and the civils and the mechanical engineers. So I know a little bit about what they do. So if you have any questions about any kind of engineering or whatnot, fire away. Let me see if I can answer them.
We're trying to add some questions in the chat for you.
Okay. Oh, going to put them in the chat? Okay. I was going to say, I didn't know if that was going to be easier. Let me, oh, I see there's some stuff in the chat here. Okay. What's the coolest thing that you've 3D printed? Okay, so I have not personally printed. I go into the labs and watch what they print. And there's a lot of stuff. We've done trophies. We've done things that kind of just experimenting. One of the really cool things. So this was the coolest thing I'd ever seen. I got this from one of the things with metal 3D printing, and I'm gonna try something here. I don't know if this is gonna work or not. I just want to kind of get you. Come on, phone, help me out. What's going on? Here it is. I'm going to turn my light on behind here. And what I'm trying to show you is kind of how hollow this is. So it's not this kind of lattice structure work is all the way through here. And that's the advantage of 3D printing is I can do anything really intricate a layer at a time and build it up. In the old days, you would have had to cast a block and try to drill through it to make it Swiss cheese like that. Now I don't have to do that. 3D printers can do some really cool stuff. One of the things that the Navy does, not so much the Air Force, that the Navy does, is rather than store a whole bunch of spare parts on their aircraft carriers, is they store a computer file of the parts that they need, or they have a CAD program, a computer-aided design program that they can design a part. And if something breaks on the aircraft carrier, they can 3D print it right there on the aircraft carrier. And all they do is carry some raw materials with them. And whether it's metal or whether it's plastic or whatever PVC that it needs to be. And it saves them lots of storage space and lots of weight carrying a bunch of spare parts that they may not need. So I thought that was a really cool use for that. So let me look through the chat here. You guys got some great questions here. So like I said, I don't 3D print stuff on a lot. We have guys doing research trying to do different things with 3D printers. And there's lots of different versions of them. There's ones that use thermoplastic, ones that print metal, ones that print in resin. And those guys are printing stuff every day. We're building, in fact, we're doing a major expansion to what we call our additive manufacturing facility. Additive manufacturing is the generic term for 3D printing. So how long have I been an engineer? A long time. I started engineering in 1985. What is that? 35 years, 36 years ago. I did about 17 years in the private sector, and I'm 20 years in the on 19 or 20 years at the Air Force Base now. What made me want to be an engineer? So that's an interesting question. I actually thought when I was in high school that I was going to be a music major, and I wanted to be a high school band director. I love music, and one thing you find out is that music and math have a lot of stuff in common when you start looking at harmonics and frequencies and rhythms and music and math. People who like music oftentimes like math, like I did. But I also liked electronics, and we had a really cool electronics class in my high school. And the more I did that, the more I knew I liked science and electronics and electrical stuff. And it was actually my high school band director who said, "You'll be much better, and if you do the electronics and the electrical stuff for a living and do music as a hobby, than do music for a living and the electrical stuff as a hobby." Because he was a big ham radio operator and he was into electronics as his hobby. And that's not true for everybody, but he could tell from me, maybe because I wasn't as good a musician as I wish I was, that it was better for me to just keep playing music as a hobby and do that. And it was the electronics and the physics classes and the experiments. I liked running experiments and figuring stuff out for yourself. I remember doing an experiment in high school where we were dropping things and measuring the time and the speed and actually trying to figure out the acceleration due to gravity. And when you actually calculate it for yourself, you're like, that's exciting. That's just so cool. And then versus being a scientist, my dad was an engineer, and he was the one who said, you know, engineers take a scientific process and create things with it or solve problems with it. We're the world's problem solvers, we're the world's builders. And he's the one that said, if you want to have a science related career, you should be in engineering, because that's the people that get stuff done. And he was right. I really enjoy being an engineer. So how long did it take to complete the metal box? That's a great question. This was actually a gift to me. I was in a 3D printing seminar, and I answered some questions right and got this sent to me. It was actually a Zoom seminar and had this mailed to me. I think this thing, there are, I don't know, there's about 120, 150 layers, 200 layers in here. Each layer takes a minute or so. I think this took a couple hours to produce. So what kind of things do we 3D print? Well, it really depends. My son has a 3D printer in his bedroom. He does most of the 3D printing here for me. The shower grate at the bottom of the shower cracked, and he designed and 3D printed a new plastic shower grate to go in the bottom of the shower for us. You can 3D print anything you want. And again, in the labs, we're experimenting with new things to 3D print, and maybe not so much what we're doing, but maybe trying different alloys or different metals and figuring out what you can do with that. So printing in metal, printing in plastic, totally different techniques, but it's the same thing. You're building up a part, you're adding to it layer by layer. With printing with plastics, they look like hot glue guns. We have a filament of plastic going into a hot tip, and it moves around, and it almost looks like you're laying down hot glue that then cools and creates a 3D object. With the metal, what you actually have to do is lay down a layer of powder, metal powder, and then shoot it with a laser to melt it, or what we call sintering it into a hard metal. And then we lay down another layer of powder and hit it with laser again, and another layer of powder. And all you do is change where the laser hits, and the rest of it stays powder. And you just keep building up a little at a time. So different techniques. So my son is 3D printed dice. He's 3D printed giant Lego men. He's 3D printing stuff all the time. He's had both a plastic one and what we call a resin reservoir style. What's the coolest, most hazardous experiment I ever got to see? All right. I have to be careful what I can tell you, because a lot of the research that we do is classified, but we took one of our more powerful lasers and we took it outdoors to what we call the outdoor shooting range. And we put an object at the end of the range and we shot it with a laser just to figure out how long do you have to shoot a laser at something to punch a hole in a piece of metal. And that was pretty cool to watch that laser go to work on that piece of metal. So 3D printing is not hard. There's lots of software out there, stuff called SolidWorks, different computer-aided design and computer-aided drafting programs that you design your part, and then you create a computer file and you send it to the 3D printer. And there are 3 basic styles of 3D printers. There's, like I said, the thermoplastic, which is literally like a hot glue gun. It's got a hot tip and it melts the plastic as it goes around and draws and just goes layer upon layer. The metal one is the powder bed and the laser fusion. It's called a powder bed laser fusion. That's how you print metal. And then there's one where you're using UV light in a liquid resin and hardening the resin as you build up the part. So it's not hard. Afterwards, you usually have some finishing work to do, some sanding or something. But lots of computer control and lots of new stuff being designed every day. How hard is it to know which wire goes where? Have you made accidental connections before? So the electrical code tells us what to do. You know, we have color coding. When you're opening up a panel, the white wires are what we call the neutral wire. The black wires are the hot wires, have the voltage on them and go to the breakers. We color code the wires either black and white or red, white, or black, red, and blue, or brown, orange, and yellow. We have different color codes for different wires. So that helps a whole lot. Yeah, as long as you're keeping your color coding the same as you go through the system, it's not too bad. So one of the things, I can't tell you all the different metals that you can 3D print with. That's one of the things our new additive manufacturing lab is going to do, is try lots of different alloys or mixtures of metals. How, you know, adjust the amount of steel, tin, chrome, zinc, whatever. You play with the proportions of them, the recipe, if you will, and create different alloys and see which ones work best. So you can use all kinds of different metals. You have to adjust your laser and that type of thing. I'm not a 3D printing expert. I'm the guy that worries about, is the laser going to be safe? The laser can't come on until you close the cabinet and everything is enclosed, or I've got proper eyewear to protect people. So I'm more about the safety of the laser than I am about actually doing the 3D printing. Did I have any other jobs besides engineering? Well, not so much after I got out of college. I didn't have any other jobs. I had a lot of jobs growing up, putting myself through college, working in the movie theater, had my own lawn mowing business. Colonel Sanders, I fried chicken for the Colonel for a number of years. I was a security guard in the dorms. I've had a lot of jobs to put myself through school, but since I've been out of school, I've pretty much always been an engineer of one kind or another. So engineer, do you work individually or in teams? That's a great question. In general, engineers work as a team. When we're designing a building, you have the electrical, the mechanical guys doing the air conditioning, the structural guys actually designing the columns and the grid, the architects on the team. You got a civil engineer who's working on the parking lot and the landscaping and grading, and you've got a team and you're all working together, very much so. As a safety engineer, I've got another safety guy who works with me. And of course, then I'm talking to the various researchers and getting information from them. And we have what we call our environmental safety and occupational health team. So I have an industrial hygienist. I have a bio environmental engineer. I have an occupational safety guy. I have a chemical hygienist. I have a radiation specialist. I have a laser specialist, and then I'm the system or the lab safety guy. And so all of us work together. We go into the lab together and work as a team to make those labs as safe as possible. What can a starting level engineer expect to make? Do you need a college degree or certificates or both? Okay, so to be an engineer, you need a 4-year Bachelor of Science from an accredited engineering school. You can be an associate, you can use a certificate and be an associate type of engineer. You would not be a professional engineer. That is a great question. I should have probably looked that up before. Let me see if I can look something up real quick on my computer. I can tell you right now that in 1985, I made $26,000 a year coming out of school. I suspect that with inflation, that is a little more than that right now for a starting engineer. Gosh, I would hope so. So let me look something up real quick. And what does a 3D printer cost? I have no idea. You can get small ones for your desktop, what they call a MakerBot. I think they're $1,500 or so. The systems that we're buying for our big additive manufacturing lab, which are huge in 10 feet tall, I'm sure that they are hundreds of thousands of dollars, but I don't know. So let's see if I go to here and I'm trying to find. Let's try one other thing here. Trying to look up a pay table here and see if I can come up with a number. But the computer is going slow. What's the biggest engineering project you've worked on, and can you tell us about it? Okay, so the biggest project that I've worked on. I designed an airport at Campbell Army Airfield down in Kentucky, as well as several, we had a lot of buildings. We had a barracks, we had some office buildings, we had some buildings out at the railhead and out at the range, and we had the new airport. All together, the cost to build all those buildings was about $500,000. No, $500 million of construction cost. I'd have to think of what the single biggest project is. Out at Wright-Patterson Air Force Base, we added 100 million square feet in about $300 million worth of construction during the BRAC process, and I was part of those. Boy, this usually isn't this hard to find these pay tables. I keep clicking where it says pay tables here, and then it's not there. All right. And let's see if this is going to help us out here. All right, so a starting engineer is going to make somewhere over $50,000 a year. I'm just looking at what the government pays, and in general, 55 to 65,000 would be a starting pay for an engineer in 2021. So, yeah, more. little more than double what I was getting in 1985. How are we doing on time here? Oh, we're already past 10 o'clock. Any other questions?
Well, Mr. Leonard, we really appreciate your time. Thank you very much for talking with us today. Guys, what do you say?
You guys had some really cool questions. You guys, sorry it took me so long to come up with the pay stuff. Usually doesn't take that long, but you guys really had some good questions. And if you like math, if you like science, if you like experimenting and finding things out for yourself, an engineering career may be what is where you should head. So good luck to you guys.